Now we have a quorum. Okay. So
Okay.
what I did today, among all the other things, is started the process of merging some of the databases. And what I'm going to do is merge them local on my computer first,
Mhm.
and then push that over to the network. So what I've done so far is I've been able to look at, I think I merged three databases into the main. I merged Hobo Gypsy, Redstone, and Quinn. And I don't know, I haven't, gone in there and checked these things carefully, but I did do some spot checks and it appears to be doing an okay job of the merging. I don't see any damage. But who knows? So the next thing I want to do is Mustang Draw, because Mustang Draw you are working on right now, and you'll be able to QC it easily, right? And tell, does it make sense or not? Okay.
Okay.
So for
Okay.
me to do that, I need you to stop working in the database
Yeah.
so that we don't diverge any further, and then like save any wells that you've got open
Mm-hmm.
and close out a Mustang Draw.
Yeah.
So have you done anything in there recently or no?
I thought what I did is already upload on OneDrive.
Okay, so the database, right now I could copy it the way that it is and we should be good to go.
Yeah,
Mm-hmm.
you can
Okay.
copy.
So I'm gonna copy that right now then.
Mhm.
And I'm gonna paste it into my hard drive here. And then I'll merge that. It'll probably take a while to copy all them files, I'm guessing. Well, maybe not. Okay, not done. All right. So let me see. See, stage one, we're gonna do Mustang Draw. Okay, so it's running right now. We'll just hopefully we'll finish that the next 10 or 15 minutes, and then that way we can
Okay.
test it here before we leave. In the interim, if you didn't notice, so we've got this dashboard now, right?
Yeah.
So, what I did here, in case you're wondering, is like on the network, we've got these folders, right? So there's the Z drive here, we've got an IP folder, and underneath that, we've got all the different databases from different clients and stuff.
Mhm. Yeah.
Okay, this program goes through there and reads everything. So like I've got the Midland Basin, I've got the Delaware Basin. We got to fix some lat longs there because those are busted. But you can see like, those are all the wells that we have from both databases. Okay. I want to get rid of the Delaware Basin, I can just go to the Midland Basin one back over here. Interesting stuff that you can see from here, right? I can like click on a well, I don't know, pick one, rattlesnake, right? It'll pop open this stuff that's got all the events and everything that happened in the well. It's got the information about the well. It's got the curves that are in the well that I can filter on, stuff like that. I can search. There's no data. There's no petrophysical data, no averages of what the bulk density is. That's not what this is for. Right. And we may be able to add that information at some other point if it's beneficial. But what I wanted with this was just to be able to understand what data we have. And the other thing that's interesting is if you look at this column here, right? Now, none of you are going to be in this database because this is the one that's been on my hard drive, right? We haven't merged anything yet. But this is, if you want to ask the question, for example, like how many wells did I analyze versus Daniel? Okay. You come to the map, you can filter it by the user. So we'll filter it by D Martinez. Those are the wells in the database that Daniel did analysis on.
Oh my God.
Okay, these are the wells that I analyzed. And I haven't even picked all of them yet. Right? Like basically everything is from me. That's all my work. Okay. There's let's see what Doug did. Right? There's Doug's work. You can filter this down and say like who ran Mineral Solver? Did how many Mineral Solver runs or auto edits or something did Doug do? That tells me that he actually worked on the well. You know,
Well,
yeah, that's Doug. Now this is over like 5 years, right? That's what Doug did.
mm.
That's what Ryan did.
Oh,
Wow.
And in case you wanted to know, oh, this is what that fucking thing will go away. I gotta fix that. This is what Daniel did. We'll make them really big.
Wow.
Now, granted, right? Daniel was in the Delaware Basin. So, you know, if we look at his total contribution over the last 6 years, that's what it looks like.
That's 6 year.
Yeah.
Oh.
Because he was working over here for the first 2 years, I think it was. Or 3 years. He was over here and then he moved over here. So he hasn't done much
Mm.
since. And all of these wells, who knows what he even did to them, right? His form of, like he just ran Mineral Solver, maybe they already existed. Like, let's see, if, you know, like how many depth shift? Like did he depth shift any wells, right? It turns out he actually did depth shift some wells.
uh-huh.
You know, you come in here,
Good,
click
good.
on one of these, and you can look in here and say, oh, you know, Daniel ran a depth shift in 2018. I don't know, maybe this wasn't Daniel, was it? No, Kyle Clifton did this. This wasn't even Daniel.
Um,
So Daniel just reran Mineral Solver is all he did, right? Because I'm not, I see here, you know, Mineral Solver, and then Daniel came in. He didn't even run Mineral Solver. I don't know, maybe my program's not working right here. It's not filtering properly. Should be user D Martinez. I don't know why that came up. Yeah, so this is actually overestimating the work that Daniel did. He just updated the well. Sebastian was the one that did the depth shifting in this.
He's gonna be hate you more.
Oh, yeah. Oh, well, if I put this in front of Corey and everyone, yeah, for sure, you know,
Oh
they're gonna,
my God.
that he's really gonna get, gonna look bad, right?
Yeah.
But this is good ammunition for the day that comes when they're like, you know, fuck PetroRes, you cost too much or whatever. I just show this to the
Yeah,
managers.
right.
You know, wait a minute. You guys better take another look. The other thing that's interesting about this is if you get rid of all these things, I can come in here and, I can make groupings of these wells if I want, filter them, but I can also come into the curves. So I could say something like TCMR, right? I want to search by that. Okay. And then it shows me all the wells that have TCMR.
Wow.
And then I can go back to my map and, it's filtered them out. So, no, it's not as nice. We can maybe still fix this. There's lots of options available, and I'm just going to write some of these things down as we're talking. So, you could have it spit out a well list file that you could use to load these wells in IP. That's not that big of an ask. We have to fix the filtering on, module and user, because that doesn't seem to be working properly, because it's showing Daniel's doing more work than he is. Who ran what, you know, like you can. It's like actually, Tube was in there at one point. How about that? 100 wells.
Wow.
Exactly 100. Load, save, update. What were you doing?
Loss.
When did you do it? Where, no, you know, I disappeared. You're not in there no more again. Now, what's going on with this? Who ran what? Show the 100 wells. Pick a well. You're not even in there.
Mhm.
Bug.
Mm.
Okay, well, maybe I too premature on this one. This just happened today, like this afternoon, so. What I'm gonna have to go back and check some of the joins or what, this is all SQL. And I had the AI do it, right? So,
Mm.
AI fucked it up or something. I'll have to go and look at all these queries that it's writing. To do some of these things. Because this clearly is not correct, right?
Right.
First and last. I guess that's the other thing I was sort of missing, but I don't see Tube anywhere in here, whether first or
Mhm.
last. It shouldn't have showed up under him. Who ran what? Last by. Let's see. Not even in the list. Not even here. So how the hell?
Where is two? Oh.
Okay, that's quite strange. Okay, so this is the result of the Mustang Draw, 38 wells, shared 30 of them, 8 new ones. Go to stage 2.
I thought it should be 39.
Says 38.
Um,
So this website, you should be able to access it
Mhm.
all the time. It's running on the server, the same server that's got the network drive on it. And then we've got these other databases as well. So, you know, we've got wells in New Mexico here, Yeso stuff. Any database that we put on the server it'll populate in here.
Mhm.
Now, what we're gonna do in the Midland Basin thing, like if you wanna, Michael's bitching about this thing, I gotta fix this. Maybe open another instance of IP instead. And we're still on 2025 also, but I don't want to go to 26 until Diamondback does, and I don't think they have done that yet, so. There's no point on upgrading because it's just incompatibility issues.
Uh,
So if you open a database like this Z Midland Basin thing, right?
See. Okay.
uh-huh.
When you can edit the database connection, I think.
Yep. I can.
And it crashes IP right there. So what you could do is create a project, right? And if you hit the create button, it opens up this stupid fucking screen, which is retarded at best. I don't know who thought this up, but they did not think very well. Slow as fuck too, right? And like, I think the idea is that you select the wells from here that you want to put in the project, and then, you know, you build it or whatever. Okay, just like forget this. Close it because it's slow as fuck. You can see what it's doing on my computer here.
Yeah.
and it's useless, right? So I've got some in here already, like a test project and a Northwest asset thing. So I'll show you what they look like. If you come in here to the Midland Basin, right? So
Uh-huh.
we're looking
Mhm.
for project files. So we need to probably put these, they need to stay, I believe, in the main folder to be visible. So it's like a PRJ. There they are. So if I open this thing with Notepad,
Mm.
it's a list of wells is all that it is. You see that? So all
Yeah.
you have to do is take a well list, rename it as a PRJ file, basically, and stuff it in there. Okay, so like if I take this Northwest asset thing and I just open it now. And I let the database open with that project and it says Northwest asset on there, right? So I know what it's opening. Okay, that's done. We'll do stage 3. So what this will do is it'll speed up your IP, hopefully, running over the network and limit you to the wells that you're working on so you don't get contaminated by all the rest of it. Now, this particular project is the Northwest Asset Project. So there used to be assets, right? Or they still are, I guess. But that's why there's so many wells in here. So you can see all the rest of the wells, like all in these counties, gone. Only the ones that belong to this asset are part of this project. That's all that I see. Now, if I wanted to, like I was talking about, I could take go to one of these well lists, let's say there's one in here like Flying Dutchman or whatever. Okay, right. I'll copy that,
Yep.
bring it in here, I'll paste it,
Mm-hmm.
and then I'll change the thing to PRJ. Yes. Okay, now I open the database again. I edit my connection. Well, it won't let me do it, right?
Okay.
Because it's open. Like I can't edit the connection of a database that's open. So I need to switch my database to a different database. And that probably was not the right one to pick because it's fucking trying to merge on it right now. And it's got it open. Stupid me. I probably fucked things up. Okay. So I go back to this one now, right? I can edit that again. And I should have another project file in there now. It says Flying Dutchman. There it is.
Right.
Click OK. And the number of reads that it has to make over the network depends on how fast this runs. So the fewer the wells that you have in the project, the faster it'll go. And the projects that you're working on you don't need access to everything, right? So there's no need to load everything. So here's Flying Dutchman, still a shitload of fucking wells because it's a big ass survey, right?
Mhm.
I don't even know. Now, if you go on here too, like there's a share folder. There's I think it's under data, like Diamondback shape files, right? So here's the Flying Dutchman survey. I want to load that in there. Okay, now I can see the survey outline. So that's why there's so many wells in this one. Still, you've got I don't even know how many that is. Doesn't say. Still doesn't say anywhere, does it? What kind of software is this that we use? I don't know. It says nowhere how many wells there are. So I have no idea how many wells this is. Stupid. but it's a lot. It's like a
Yeah.
couple hundred
Mhm.
wells, right? Probably. There's seriously no way to fucking. These are all the wells, so it filters the whole thing to the project. There's still nothing that tells how many wells there are, right?
I have no idea.
Yeah.
I don't know. Anyway, this is what you'll do. Okay, so you create these projects, work in the project. You know, that so you don't have the whole 5,500 well database.
Mm.
And then we won't have to worry about merging ever again. The only merging that we're going to do is going to be between our stuff and Diamondback on their server, which I'll take care of. And then you can use these sort of things, you know, these maps and dashboards and stuff. You know, I'll put something in here to create well lists or whatever. You can search in here, right? Something that you can't do in IP. Like an IP, you're going to say, how I want to make a project with all the wells that have CMR data. How do I do that? Well, I can't. Right? I can do it because I've been building SQL databases for the last 6 years that I keep on my computer.
Mhm.
And then I come in and use LinkPad and write my own queries to search those, which is still a pain in the ass. Right? We often get asked questions too. You're going to get, you know, daddy's been kind of babying you all, but this is going to stop soon. So you know, you're already seeing the effects of it. Like, somebody like Jorge says, here's a list of API numbers. Go work these wells. Well, let me just write that one down too. We need to be able to enter a list of API numbers to search on. Paste a huge list of it. Because that's going to tell you which wells we have in our data set or not. Do we even have all these wells? We might be missing some, right?
Right.
So you can do that and then come back to them and say, well, we've got, you know, 10 of these. We're missing the other 10. And then they've got to give you the last files for those to finish your project, right? But it's good to see if we have them already. Do they exist? Right? We've got to clean some of these databases up probably also, particularly the Delaware Basin one, because you know who was working in there. The Midland Basin one, I pretty much fixed most of this. Look at all the API numbers are exactly the same. They all have the same format, exact same number of digits, right? That's because I was doing it. Over here, Delaware Basin, right? Let's see what the API numbers look like. I don't know why these, like relative to the number of points. You know, some of these things, I think I even maybe affix that data. No, there's API missing, right? Some of them are the right number of digits, some of them aren't. Other, right? You probably aren't going to work in this too much, but there's a whole bunch of wells that are in Eagleford and TMS or whatever. Yeah, here's other. So these are wells that either didn't have sufficient data, they were never really brought over to the Permian Basin database because they didn't have a lot of good curves in them. They're like G1s, or they were in the Delaware Basin. So, you know, we need to do, there's lots of things yet. Lots of things yet where, you know, we could merge some of this stuff. And we have to, you know, think about it. We got one Delaware Basin project, we got one Midland Basin project, and we shouldn't have, you know, maybe we need to make one for the Central Basin platform or something. I don't know, but we shouldn't have any wells in the other database that aren't in. Like here, you know, you got stuff up here in North Dakota, right? Bakken or whatever. You went to DJ Basin here, you went to Basin over here, things like that. San Juan River Basin up here, New Mexico, Colorado. This is kind of where Eric, he's got a place up in Durango there, right? anyway, so yeah, there's lots of opportunities to search all this data, but you know, if you ask the question, well, gee, you know, how can I tell which wells are in this database? And also which ones are in the Delaware database and which ones aren't? Well, at least now we've got the ability to create, you know, a list. So I can see which wells are missing API numbers. I can see, you know, what's going on here. I can, you know, cross-reference this stuff. So that'll be coming at some point. I don't know when, but we're gonna want to clean all this up and get
Mhm.
it so that, you know, we've got one definitive data set. And same thing here, like I've got wells that I'm working that are in the Midland Basin and then the Central Basin platform. Do I really want to separate these into different projects? Probably not. So maybe at some point we just put everything into one gigantic, enormous project. I don't know, or a database rather, and then we split the projects off to be small enough where it doesn't. At some point, I think what's going to happen is we're just going to stop working in IP, hopefully. Right, that if we can get our own software much more efficient, streamlined,
Mhm.
does a better job, we do all of our work there, and we just export it back into IP. Right now, we're doing it the exact opposite, right? We're working in IP, and then like we're exporting it into Studio to work on it a little bit there or whatever. But I prefer to like work on it in the studio and then fucking blow it back to IP for the client.
Mhm.
Because we could do, I think, we can do a better job than IP. Less clicks, better results, but that's gonna require a bit of testing yet to get there. All right, so we're still merging Mustang Draw, it ain't done yet. David Jenkins, where's David Jenkins? There's David Jenkins. David Jenkins did more work than Daniel.
It's a little.
Even Ben was in there. Ben's got one well.
Ah,
Um,
There it is. One little well. Where's it at, Ben? Martin
It's
County.
not bug, right?
yeah.
And these guys, this is QEP, right? These are all the QEP wells that we had.
Ah.
Dave Ratcliffe and whoever 10266 is. Joe Beck, 141 wells from Energen. That's what he did.
Whoa.
Oh, big.
Okay. I think it's time to do stage 5. Just merge it. Okay. So 3 wells have the same API number in your database. Did you know that?
Same API. Wow. Was.
uh, I don't know.
Oh, it looks like you got 2 wells that are the same. But one of them, they got different names. So there's 2 wells in the database that are the exact same well. Are they sitting over the same position and everything? I don't know.
Ah, I think it might be red 28 3D.
That's what it says.
We have 3D We
Yeah,
have,
but are these the same well or not?
it's not the same.
Then why is the API number the same?
Yeah, but
You got two wells basically sitting right on top of each other here.
But it shouldn't be the same, right?
I don't know. I'm asking you. I didn't work this project.
Mm. Twenty.
Is that the same data?
And
Looks like the same data to me.
27. What?
Same well. We just found that in this whole mess here, right?
Right.
There it is. It says, hey, you got two wells that are the same API number. That creates a problem, right? Which one do you merge? So you need to make sure when you work in these projects that you don't have redundancy like this and that you clean these things up, you know? But that's the same well. Only thing that's different is the depth interval on them. Whenever the data was loaded or something, this well was clipped and this well's got spectral gamma ray data that goes all the way to the top. So I guess the correct well to keep would be this one and delete well number 20. So let's see what happens here with this merge. It may take a while. I don't know. But once it's done, what I'll do is I'll run robocopy or something like that to copy the changes over to the Z Drive database. And then this stuff should show up in there. So what you should do then is go through these wells in the Z Drive database and make sure that they all look correct. You should see all the changes, all the edits, all the stuff, all the work that you've done should be there. If it's not, then there's a problem. Check all of them, right? Go through a spreadsheet and check all of them to make sure that they're all correct. And then
Yeah.
if it passes that test, then we, this is actually a fairly decent test, that because we've got duplication and some other things.
Try to see.
So I'll let you know when we complete this, and then finish continue your work on this Mustang draw in the Z Drive database. And we'll see how,
C drive.
yeah, but
Mhm.
again, you'll have to create a project file for the wells. So that you don't have all 5,000 sitting. I'm sorry? No, not yet. This is the first one that we're trying. I did already Redstone, Queen, and Hobo Gypsy because those are old and they needed to be merged anyways, but the next one that we'll need to do is the ML, and that's where we get more complicated because there's gonna be duplication Like you got lots of duplication between the Core Lab Title Consortia database, the ML database, the Hobo Gypsy database. Right, so when we overwrite, and hopefully this finishes sort of quickly, I'll show you what happens, this merging process, you already played with this a little bit, I think. But, there's the ability to overwrite curves, there's the ability to create a new set. So that you have multiple sets, like you have a mineral solver from Pond, a mineral solver or whatever from Hobo Gypsy, it'll be like 4 of them. Or you could do curve suffixes, so it doesn't overwrite the curve. It'll just put like an underscore RB on the end of it or something, or underscore Hobo Gypsy or whatever. And then somebody's got to resolve all those conflicts. So I don't know what we're gonna do yet. I think what we're gonna have to do is take a couple of key wells from Hobo Gypsy and the ML database, and then cherry pick and figure out what's going on. Like the ML database, I think, especially after all the recent work that you've done in there, that's going to be the definitive answer for mineral solver and clay and TOC and things like that, right? But rock physics is going to come from Hobo Gypsy. And core data and lithophase stuff is going to come from the Core Lab Consortia database. So we'll have to set up some of these merges to where we cherry pick certain data that comes from here. Like I'm not going to overwrite my mineral solver from the Core Lab Title 1 because it's probably not a very good analysis. The ML database one will probably be better. And then
If we
the other
want
thing that
to, okay.
Well, the other thing that we can continue to do as well is keep, the UWI numbers in the wells to help us identify things quickly, along with well lists. You're going to have to very heavily rely on projects and well lists from now on. So, somebody asked that question, ML database. I want to load that. How do I do that now? Just the way that we did. You create a project file. You have to load the ML database project file, or you've got a bigger area and you have a well list for the things, or, I think we had like put an X at the end of the UWI number or something like that. Then you look at all the wells with X's and that tells you or something like that, right? And what's going to end up happening now also that we've got all this cool infrastructure in place that we never had before, right? This all kind of happened within the last couple of weeks, really, right? The last 3 weeks since we bought that hard drive, is that now we have the capacity to expand this. Because before, I was really apprehensive about expanding anything before we had something in place to handle large data. Now we can expand. So, I can take a dump off of Diamondback's, geo database. Could be hundreds of thousands of wells, and load a bunch more of those in here. And we can have, we can manage that because we're working in projects. We've got all the things in place to make these maps, to filter stuff, whatever. Because what I don't want to have happen is, you wind up with a database with 100,000 wells in it, and it's so much noise, I can't find anything. You know what I mean? Like I need wells, this is all garbage, I don't care about these, I need wells that are important. I can't find any important wells, all I can find is noise.
For the
So-
project, do we need to create for everyone? If I want to
It'll be in there.
interpret Mustang draw.
Yeah, it'll be in there, right? Because it's in the folder. So like if you go look in there right now, you're gonna see this Flying Dutchman thing.
Mm-hmm.
You should be able to load that, try that. Go in there, open, open database, go to your Z Drive project, Z Midland Basin. And then you edit the
Mhm.
connection, and when you do the drop down on that, the same exact as me, you should see those PRJ
Ah,
files.
okay. Okay.
But we
Um,
don't know what the Mustang draw well numbers are and all that stuff yet until this thing finishes and I move it over.
Mm-mm.
Because it's
Okay.
adding new wells that didn't
Uh-uh.
exist in the old one. And I need to fix that rage duplication problem as well. So
if I save the work that I did, it will be override to database or it only save to my project.
no, this is going to the same database that everybody's in now on the Z drive. So the instant that you save a well, it's saved there. There's never has ever been your own database. That never happened. Even when you're working on OneDrive, you're writing to a database that gets updated to everyone. Now, the thing that we've got in place now is with all this stuff I set up, right? You should be able to go into these things. Like, I don't know a good example of one of these. Let me see. Just
Midland.
pick one of these wells and hope that it's one that was changed. Maybe I can. I don't think actually any of these were changed yet, but you should be able to go into the properties. We've got previous versions. There should be a list of previous versions, version control. I've got backups and stuff. So, if something happens where there's a crash mid-right or some other weird network problem where the well gets corrupted or something
Mhm.
bad happens, we have sufficient backups, like nightly backups are going to the cloud. I've got Restic set up and B2 cloud storage, right? I've got the bucket here, like it's 581 gigabytes, right? So data's going to that. I've got data duly redundant on the laptop. I've got 3 hard drives on there now.
Mm.
One 4 terabyte and 2 are 1 terabyte drives, but the IP databases are all getting backed up to 2 of the hard drives. And we have snapshots on top of it that are happening like every hour or something like that. So if there is like, a problem like corruption or something, or Pawn flips out and decides that she wants to delete all the wells and then fucking jump off her balcony or whatever, right? Then all we lose is the last 15 minutes or 30 minutes or whatever the snapshot was, because I can go in there and restore everything.
Ah, okay.
So this is completely impervious even to like a bad employee that wants to delete all the work. And then by the way, I've known several people who have done this, right? And they
Huh.
one actually got sued by Devon and had to pay like 300,000 US dollars back to them for damages for what he did. Yeah, Don Westacott. I don't know if he's retired or not. The last I checked, he was the core vault guy for Halliburton. Anyway, so the whole point is, IP is going to continue to have this. We have to make the database shareable. We have to check that stuff, right? I don't even know what I've gotten here, right? These ones you can go in there and you can say like well sharing information, right? And we can set the database up so that I don't even know where you do that. I think well sharing information. There's somewhere else that you go in here. I think maybe it's in the settings, options or something, right? It's been a while. I see they actually finally changed this. That would be nice. Fucking DMS. I hate DMS.
Setting sharing the well, right?
There should be, yeah, I'm looking for something in here. I don't know where it is.
You need to right click on the well name.
No, here it is. Well Security Manager.
Ah,
You have to come in here and then you have to tell it which wells are enabled for sharing, right? And then you can do allow multiple users to use the same well concurrently.
yeah, right.
Like if you
Yeah.
click on that, it's gonna tell you about how that works in IP. Where there's conflict resolution. So if both of you write to the same curve, then it pops up a box and says, hey, Tube wrote to the final mineral solver thing and Ploy wrote to the mineral solver thing. Who wins? See, it pop one of these guys open here.
Yeah.
So
Mhm.
what we need to make sure that this is set up properly for that like 5,000 well database, which I don't know that it is yet. But we'll check that. And then once that's done, you can have multiple people in a well. Otherwise, what'll happen is if you try to load a well that Tube has got open, it's gonna tell you. It's gonna say, sorry, you can't load this thing because Tube has it open.
Yeah.
And it'll say, hey, but what I can do is open it as a new well for you if you like. And don't ever do that, please. Or if you do for some reason, like if, we're in a situation where we have to do that, make sure that you don't save the fucking thing, because then what ends up happening is we get copy of well, there's like all these
Mhm.
redundant
Yeah.
copies of wells in our database.
Right.
That's how that happened originally. Is IP says only one user is allowed to open a well at a time. They lock it for write access and they've got control over that well. And anybody else that comes
Mhm.
into it has to open it as a new copy. And then that person that inevitably hits the save all button. And then all the fucking copies of the wells are written to the database. And we've got, the Boone KS Deep 1. We got the copy of Boone KS Deep 1. We got the copy of Boone,
Yeah, right.
and then we don't know which one to use either.
Mhm.
All right, so this thing is done, minus the
Good.
2 wells that it couldn't merge, which were these ones.
Mhm.
So we will take that into consideration, but I think I've got, so let me do this now. So I'll compare the well, the 2 databases. And it's gonna tell me the differences between the one that I've got on my hard drive and the one on the Z drive. The one on the hard
Mhm.
drive, I've been merging everything. So I've got 193 wells that are different. And I got 9 new wells that are in the merge database that we've been playing with, right? Because they've been added from Mustang draw or from wherever.
Mhm.
So 202 files or whatever need to be copied over. Some of them are kind of big. So I'll run this then and I'll let you know when it finishes and then go in there and check.
Mhm.
And the only thing that's going to be missing is the rage well, which we'll have to copy over. And I don't know, it sounded like based off of what we saw here, is that this well, it couldn't find a master for. And then these wells, it's not, I don't know if they were already in that database or not. So that's, here we go, right? This is the perfect example of how we use this web thing. So I want to know, do I have that well in here? There it is. That's on the Z drive now. This is all built off the Z drive. So I do have that well in there.
Mhm.
Okay, who touched this well? This is like, who touched the little girl on the playground? Who touched this well? I touched it. Did you touch it?
เว้ย
จับได้ไหม
ได้
ห้ามจับ
ห้ามจับ
น้องจับได้ไหม จับหน่อยได้ไหม น้องจับหน่อยได้ไหมครับ
โอ้
So I don't really know much based off of this. It looks like nothing was done. Somebody renamed the curves. That was it. So the well number, does it even have that in here? The database number? I don't even know. 5119. There it is. So, the old way of doing these things too, which is ugly, but this is how we would do that. So I would say, save current well as,
Mhm.
and then I'd come over here to my D drive database. Notice all my fucking things are red, right? I'll drop it in here. I'm gonna leave that, and I'm just gonna let it save it. Okay. So we're resolving this conflict. And the other thing I need to make sure of is this well, Mighty Mo, right? I think Mighty Mo, he's in a lot of databases too. He's in the ML1. I think is he in here? There he is, right? So Sebastian loaded that thing up, and that was the last thing that was done to it. So you've done work since then on Mighty Mo. So we need to check Mighty Mo. So let's do that. So I think I got one IP open, right? So we'll open the Midland Basin project on my D drive.
Mhm.
We already know on the Z drive, which is not the same one, but it's similar, that the Rage well was 5119. So I can see now that I've got, we won't know where that thing landed. That's one of the problems though, because it fills in gaps in the database numbers. So like if you delete well number 1, the next well you save will be well number 1. And there's no easy way to search this. So what we'll have to do is set a filter. And I'll just put Rage, right, was what it was called. There it is. So now I can see where it saved them. So it saved it as well number 1058 for whatever reason. I've actually got both of these wells in here. So there's all kinds of redundancy, right? This one, I know it's done. That was the one that you worked on, right? If I load this well and I look at it, it's got an analysis. It's done. These wells, nothing was done in here. I got a final set, but I don't have a MSOL set. This was a David Jenkins special. And then this thing has just got a raw set with 183 curves, which is interesting because this well doesn't have 183 curves in the raw set, does it? So now we're missing information. That's not good. I also don't see a thorium or potassium or anything in there. They're in the well, I guess, in the edit set. I don't know how they got in there. Petro, there's 140. That's David Jenkins bullshit though that comes out of his. Okay, so he put it in R1. I guess I'm not seeing. Well, hold on a second. He's got all the resistivity curves and stuff. There's a mud log in there, which I don't know that I really care about. And he's got the mud log here anyway, so fine, checks, right? Nothing wrong with that. So these two wells, delete. Right, there they are, 5143 and 4895. There they are, delete. Do you want to really delete these two wells? I sure do. Get rid of them. Yes. Okay, they're gone, right? Close the well, save the well. All right, now I got one Rage well in my database.
Mm.
Okay, second thing that we have to check was the Mighty Mo. Ah, there's two of them.
Mm.
So I got one that came from somewhere. And it's got an X on it, which is really suspicious because it seems like that may have come from the ML database, which means somebody merged the ML database, which I don't recall doing.
Mm.
And then you got this one. So
Mm.
this is the problem I'm talking about, right? So this
Yeah.
well, is this your analysis? Is this what you had?
Here's my boy.
This is yours?
Yeah.
I go into the header and I look at it. I don't know. I don't see you in there anywhere.
What?
Right?
How?
It means the well didn't get copied over. And then we got this well. Also, I don't see you anywhere in there. This was all done in February, right? This is all stuff that I did. So in our merger, we had a problem where it couldn't find, you know, the parent for these two, so it kind of puked. So back to Mustang Draw we go.
Mhm.
So this thing has an ambiguous master, right? So it didn't merge
What it is?
that well because there was a duplication already in this database. There's two of them. So it said, which one do I merge to? I don't know. So what we're going to do, I guess, is we'll look at these and see if, so you got basically the wells appear to be the same from what I can tell. The big difference is just going to be dates on them and what was done. So let's look at these again.
Okay.
So this was last saved August or February 18, 2026, right? Let's see what that's 792. Let's see what this one is. February 18, 2026. So as far as I'm concerned, these things are identical. I couldn't tell you why there's two of them. I'm just gonna assume that the second one was some right that we didn't care about. I'm just gonna delete that. All right, now I've only got one Mighty Mo. So if I run this thing again, which is a pain in the ass that I have to do this a second time, but it'll go through, it'll find this. It's only going to see one well that hasn't been merged. And it's going to say, I can merge it now because there's only one in the master database. It's not ambiguous anymore. And then it'll go through. So I'll have to do this. It's going to take a little bit, but when I'm done, it'll be the last well that needs to go. And then what I need to do after that is copy the changes from my hard drive over to the Z drive. And when I'm done with all of that, I'll send you a message.
Yep.
And then what I want you to do is load the Z drive project, go in there, pick out all your Mustang draw. If you need to find the shape file for the survey, you know where it is now, right? It's on the
Yep.
share,
Mm-hmm.
Diamondback, shape files.
Mhm.
And, you know, build a well list or something from those wells, make a project. Load the project, go through the wells, check the wells, make sure that everything looks the way that you left it on your OneDrive project that you've been working in. So none of that's gonna happen until we finish this one well, because we didn't catch that one. It was a mess. The other thing too is, you know, as you play with this thing and see if you find any problems with it, just write them down and send them to me so that I can get it fixed, because I don't know. There's lots of bugs in this thing for sure. But and any other thing that you can think of that would make this more useful also, you know, for some of the work that you're doing. Like I say, just being able to find wells and figure out what's in here. I'm gonna make some changes. I got a little list here where we're gonna be able to paste lists of API numbers and have it tell us what's missing and stuff like that. We get these projects. And we also need to be able to figure out, you know, where we got problems and go in there and fix them. Like lat longs that are messed up, or API numbers that are messed up, or whatever that we need to make modifications to. So, I guess, you know, after this, the next one that will merge will be the grant database.
Yep. Okay. Next week.
Yeah, so keep working in the grant database on OneDrive
Okay.
for now.
Yep.
Until we get that one merged. We want to make sure that Mustang Draw goes through clean first.
Mhm.
All right,
All right.
anything else that anybody wants to share in interesting problems, questions, complaints?
Yeah. Can I share screen?
Mhm.
Me and Poi working on. Me and Poi working on the saturation things.
Yeah.
I will open the map. I will pick the saturation. Okay. And sat P50. Okay, I will. Okay, wait a minute. Reclare also. Oh,
Series.
no. And burn it here. I thought we need to recheck this well
Yeah,
first.
that well looks a bit odd, right?
Yeah.
Yeah. And what do you think about the self-NS?
It might be a bit high also, right? I don't know what the, you have to pull the logs open and look at them. What have you got going on there? Is it a top problem? Is it
is.
a washout problem?
It's washout. It's washout. Self number 6. Okay. I checked the density is about 2.5 on the average map.
So you got your final curve there versus your MLR. There's a
Mhm.
reason that that track exists in all these plots, because it's incredibly important to look and see what happened. But in this case, what we actually want to look at is the final versus the edit. So change that from edit, delete that underscore MLR part again, like we did last
Oh
time.
yeah. Okay.
Okay. So just hit OK or whatever. We don't.
Mhm.
So yeah,
Got
just
it.
get that thing out of there. All right. So the data, if you zoom in on that some more,
Some more. Okay.
yeah, the data in this is interesting. So you've got quite the significant washout,
ใช่
Mhm.
and you have not so much change in your density.
Yeah, right.
So the Chester, right? You've got top seems to be off a little bit there too, but you know, you've got some things going on. You can see it. In the Barnett, I can't see everything because some of the stuff is off scale, but it appears as though the worst part of the washout is in the upper 2/3 of that, which is not uncommon. And I would be willing to bet that the Neutron and Sonic are probably off more
Neutron
than
and Sonic.
than
Mhm.
the density. Yeah, you know, you probably
Mm.
need to make a second pass at that. And
Mm.
the other thing you could try doing as well is running the light GBM bulk density that's been,
Mhm.
you know, filtered with the that whole flag.
Yeah.
Just
I will
stay
try.
with that, you know, with that one well and kind of run it over. You could try a couple different passes. You could do one where you run it over the whole well just to see what it does. And the other one is you can try to constrain it to the bottom 2/3 of the Barnett, or bottom third of the Barnett, where you've got decent data, and see how it predicts the upper part.
Mm.
But I mean, all of these things, I can't really tell you what to do. I can only tell you what I would do, you know? And I would, you know, that doesn't mean this is all interpretive, you know, depending on how you work it, you're going to get a different answer. But what I would do, you know, depends on what I see. So I would be running these regressions first, playing with the data
Mhm.
and seeing how it reconstructs. The problem is with a lot of these regression algorithms, you know, having 10 points is not enough to build anything meaningful.
Ah.
So that's like I say, you run it over the whole well, filtered by the bad hole flag, and maybe the decision tree can kind of figure out what the Barnett would look like, even though it's
Mm.
never seen it, you know, and then see how much different that is, kind of fix it up. And at the end of the day, all you're doing is massaging these maps so that they look a little bit smoother, you know. And if a client came back and said, well, you know, what the fuck, here's the thing. You got to look at it from the consumer standpoint. If they have a map that doesn't have those bullseyes on it, they're happy. They don't know any different. If they have the bullseyes, they start asking questions and they look. And then it makes us look bad. And it's like, well, why did you give us this? And you can explain yourself away and say, well, the data was bad and we had to edit it and there was nothing there, sir. And, you know, they're going to still say, well, why is there bullseyes? You did a shitty job. Where if we don't have the bullseyes, if someone did come back to us later and said, oh, this looks really smooth, like, but it's not right, or there's something I don't like it.
Mm.
It doesn't. So I started looking and like, man, there's a lot of washouts. How did you do this? Then it's easy to say, well, we had to make a decision. We no longer know what the actual answer is because we're interpolating.
Mm.
But we interpolated in such a way that we made a geologically consistent map or a smooth map or whatever,
Mm.
right? So it's not that we're doing an Alex where we're destroying information that we have that's good information. Here, we don't have any information. We're making shit up anyway. So how do you want to make it up? Right? The things that bother me is if I see a decent hole, good hole, and I see weird shit going on, like what Alex did, right? I've got good hole and then I got porosity there, but he wiped it out. Gone. That's bad. Here, the answer is already fucked. Like there's nothing you can do but try to reconstruct it. So being me, right? I'm an engineer, I'm a fixer, I'm a problem solver. I throw everything I can at these things to try to get the best answer that I can. Instead of just being
Okay.
like Daniel and throwing my hands up in the air and saying, it's washed out, there's no data, I'm not going to use it. I'm throwing it away. You know, it's like having a girlfriend or a boyfriend that's got, you know, one hair that's too short, or, you know, you just dump them, throw them away. They're not perfect. No, it's not how we work, right? Things are
Right.
imperfect in this world. We can still make them useful, even though they're imperfect. So, yeah, so what? Big deal. It's washed out. Can we fix it? Yes, we can. This is where interpretation comes in, the way that Ploy does it, the way that Tube does it, the way that Daniel does it, all different. And now you see why, because somebody uses an MLR, somebody uses light GBM, someone trains over the whole well, someone trains only over the Chester, someone uses offset data, someone doesn't use offset data. In this case, maybe that's one of the options that you could try, right? Run multi-well regression with light GBM, but use offset data. Don't use any data from that well because it's all fucked up in there. So use the Butler, use the University 29 or whatever, use these other wells to predict what the bulk density and neutron and sonic should be in the Barnett, and then make a plot like the auto edit splice plot where you can see the final curve versus the light GBM curve, see how much different they are.
Okay.
You're the interpreter, so which direction is the density moving in? Is it interpreting it less dense or more dense? If it's less dense, it increases our problem. It makes it even brighter. If it's more
Right.
dense, we know that it's going to make that bright spot dimmer. Right? Same thing with the
Right.
Gray County School. Why is that thing so low? Is it low because the Barnett's gone? That's possible. Or is it washed out again? So it looks like there's a whole pile of carbonate in there. And it looks like the well's in pretty decent condition, but you've got really high density
Yeah.
and you've got sort of a fast sonic and sort of a low neutron.
Right.
So it looks like tight rock.
Fix.
You know, like I don't know that I would change that. I don't think your geologic trend is that bad if you got rid of that self Inez well. If that thing went out of it, now I've got a story. I go from high porosity to low porosity. That's the only problem with this, is the self Inez. So use the Butler, use the Gray County for training because they're on either side of it, and interpolate in between. Yeah.
Yeah.
Hopefully. Okay.
Got it.
Easy. Yeah, and you'll you know,
Easy. Mhm.
if you do that, you'll make it so that you have a transition from one end of the basin to the other where it makes sense. And you also have missing data, right? There's missing data between, you know, northern part of Martin County and where those wells are. And it doesn't look like a whole lot on a map when you're staring at it from 300,000 feet, you know, elevation, like a satellite. But that's actually a fairly decent distance geologically, right? You're talking about each one of these counties is what, 30 miles? So on the edge, that's like help me out here, 45, 50 kilometers or something like that. 40, 45 kilometers maybe. So you're still, 5 kilos, something like that, 6 kilos. So things can change,
Mhm.
especially when we look at some of
Mhm.
those structure things that we were looking at before with the 3D property model
Ah,
building, right?
right. Yeah.
There's thinning of the structure and there's depth changes. So, this stuff disappears and maybe it disappears. That's the last little 6 kilometer tail of this thing, right? And it's gone.
Okay.
Let's look at your
I will fix them.
saturations real quick. So that's
So-
porosity.
Oh, good.
Yeah, so you got the exact opposite problem here, right? You've got
Right.
high porosity wells that have low saturations, and you've
Right.
got low porosity wells with high saturations. And this is typically what happens. Because if you go over to your Gray County School log plot and you look at that thing, what happens to the saturation when my porosity gets near zero? Right? What's Archie's equation? What's in the denominator of Archie's equation? Phi to the m. So when phi gets to be really small, the math works out that you go to like infinity, right? That's what ends up happening. And it clips it off at 1 or whatever, but that's why you always wind up with really high saturations with low porosity rock. It's an artifact of the mathematics. And it sort of makes sense in many ways, that if you've got 1% porosity, can I really flow oil and water through 1% porosity? Can it hold both of the phases? Like if there's no storage, there's no permeability, there's no migration pathway, and buoyancy, the capillary pressure forces are not enough to drive that water out of that 1% porosity pore. You see what I mean? Like it just can't push the water out. So it's going to
Yeah.
stay high water saturation. It's not until you get to
Mm.
bigger pore systems with, the miscibility and all that stuff that you're going to be able to do that. So, that's why you tend to get these things. RK Glass and Scarbauer, I think I'd want to resolve a little bit because the scale on your plot here is pretty extreme. Right? You're going from 30% to 70%. That's a lot of water saturation change. So if you change that scale, you're going to see these things are a lot nastier than you think. Go from a 0.2 to a 0.5. That's still 30%. That's 30% difference. Oh, 0.2,
0.2.
20%.
20%.
Oh,
Yeah. So all those things that are blue and green are kind of like, they're cool, right? They're copacetic. And all the things that are yellow are screaming at me that there's, bah, something's wrong. Better check them. And, part of these too, I think, synthetic resistivity. The
Right.
RK Glass and the Scarbauer, I think at least. The Holt, I think one of them has synthetic, the other one doesn't.
No,
But,
this one.
but why are the,
Mm.
why, if the porosity is not that low, why are the saturations so incredibly high? This is again, when you finish with these sorts of projects and you're doing this last little bit of interpretation, fixing these things, which is also one of the most important parts of petrophysics, and it's the one that requires some of the highest skill.
Mm.
You need to look at these data sets together. So when you make a picket plot of all the fucking wells together all at once and look at, don't color it by form, but you got all Barnett, only Barnett, color it by well and see how different these things are. You're going to see the differences between induction logs, between lateral logs. You're going to see differences in the data sets where it's just washouts or whatever, right? And you're moving these RW lines around and shit to basically, fix that. this is the petrophysicist is manually normalizing as the last step. That's how you're doing it. Change the point styles. Yeah, I hate them fucking X's. Whoever decided to default to X's needs to have their head chopped off. It's probably Paul Spooner. Next time we go to SPWA, you like put some bad bala or something in his food so he gets sick, you know. So
Alright.
select, just double click on Barnett, select all the Barnetts. Okay, now you go to the, well, curve set.
Mhm.
So now you're gonna have to start, you know, culling this down because there's so much noise in some of these, you know. So start looking at, you know, maybe not select all the wells, select one well at a time and just keep adding them to the plot
Okay.
and see where you get changes. So like there's one Barnett, right? Okay, so all of a sudden we've got two
So-
wells that are the same color too on top of it, which sucks. We
Why?
should- Yeah. I don't know why that happened. That's another Paul Spooner problem. Poison Spooner, poison tea. Okay, these two
Okay.
wells are not too far apart from each other, right? We've
Right.
already
Right.
identified the Gray County well as being tight, as being low porosity.
Mhm.
We see that.
Yeah.
Yeah.
We also see the exact same shape of the data, except what's different.
What different?
The porosity is higher. That's the only thing that's different.
Mm.
Slope and everything else is the same, right? Just the porosity is
Right.
higher.
Yes. Yeah.
So
Porosity.
that if we fix that well, it may drop it down some. Which means the
Oh, yeah.
saturations are gonna look the same and the porosities are gonna look the same and things are gonna start looking the same. Pick the
Ah,
university well next to 16 or whatever it is. Salmon colored, right? So salmon boy and purple boy are looking the same there.
Mm.
So we just have the one odd well. Pick the
University.
university 17.
Mm.
Ah, now we got something sort of in between. And we got something weird happening with this data. The other wells don't have it. This well's got this little shark fin on it, right?
Yeah.
Right.
High
Shark fin.
resistivity. Yeah, well, what's that? That's organics. Now I've got a big chunk of organic shale in there that I didn't have before. How does that change our saturation interpretation? It doesn't, right? Our wet line is still where our wet line is. All it means is that the water saturation is going to be really low where the shark fin is because there's tons of organics or there's high resistivity there. And high porosity both. So, you know, just from looking at several of these wells, I could tell you already that, you know, yeah, now we got something even different. Now I've got transition. I've got transition
Orange.
horizontally. It's moving horizontal across this plot,
Mhm.
right? Starting off in the same section, the same
Yeah.
thing where that Gray County is, which means I've got some things that are low resistivity, high porosity,
Yeah.
wet looking. And then I move over, right, to the shark fin area. And I've got everything in between. That stuff on the bottom is probably just noise and garbage, right? All these little points that are like 3% porosity or 1.5%. Don't worry about them. But this also makes me question this well a little bit. Because why do I have 5 ohm meter 10% porosity in here? Is it washed out? Is it washed out, right? Are these washouts? I don't know. So anyways, I'm gonna go get my dinner because it's been sitting downstairs for like an hour now. And I'm
yeah.
gonna eat. But
Okay.
continue this
Mhm.
process. You have to make the decision ultimately on what to do.
Yep.
So you know, all three of
Yeah.
you get together and discuss this, right? Look at the data. And
Okay.
put together a plan on what you think is happening in the Barnett from well to well, right? Like you can, you could do something really simple, like add a discriminator to this cross plot where your bad hole flag gets rid of any of the
okay.
points where it's bad hole. Right?
Yep.
So that's the first thing you can do. Stuff like that. And kind of look at trendology, look at the differences that are happening, because you do have wells that are up on the platform that are south in the basin that have a lot more shale. They have a lot more clay bound water. They're going to have higher total porosities.
Yeah,
They're going to
right.
be different on trend because of that. So you're not gonna want to normalize everything. But what you do want to do is understand the overall trend and where your outliers are in this data set. And this plot tells you a lot of things because it tells you if you got your porosity wrong. So you're gonna find wells in here that just have way too high a porosity or way too low a porosity. And that tells you where you need to do the rest of your edits. Right,
Yep.
based off of how all this stuff plots. Like that well that you just pulled off there, that last one. That guy's a different trend than all the rest of them. Look, he starts at like what, 15% porosity. That's wet, 15%. And then goes down. That well there, whatever that is, number 36, I'd be willing to bet that that porosity is biased a little bit high for some reason, maybe due to editing. Doesn't mean you need to change your well completely. Just go look at it and convince yourself if it looks right or not. If you go back to it, you say, no, I'll stand by that interpretation. I think that's correct. Then no problem. Otherwise, if you look at it and say, no, that doesn't look right, that university well should be plus porosity, then fix it. You found something. You know?
Okay. Okay, I will go check and
Yep.